Continuing on the kinetics unit, the objectives for this screencast is to describe suitable experimental procedures for measuring the rates of reactions. Now that we're talking about kinetics and the rate of reaction, how do we measure how the concentration of a reactant or a product changes over time? Dave would also like to know, how would you design an experiment to measure rates of reactions? All right, measuring rates. Different techniques depend on the reaction. We can measure a change in volume of the gas produced. Kind of obvious, you have to produce a gas. And you can do that one of two ways. You can set up a syringe setup as shown down here on the lower left. Syringe with a reaction mixture, a stopper, and the gas is directed to the syringe. Or you can use a same kind of setup with a stopper and a tube where the gas is directed at the bottom of either an upside down burette or a eudiometer tube. Remember, in this setup you would have to subtract the if there's any height difference between the height in the beaker and the height in the burette. Do a change in mass. Okay, if you're going to again be given off a gas in the course of the reaction, you can put the whole reaction mass on a mass balance and record the change in mass over time. If there is a change in the absorbance or transmission of light, meaning is there a color change? Does my product, is it a different color? Does the color of the reactant change? We can use that with a colorimeter. Okay, light source, there's a lens, there's a prism, the sample, and then there's the detector. We should have did something like this last year using the cuvette with the colorimeter and Logger Pro. It is possible to actually use titration to calculate the change in concentration. So in some reactions it is possible to measure the concentration by titrating it against a solution of known concentration. But you have to be careful because titrating does change the concentration of the solution, and you can't do this continually. So instead you have to remove samples of your reaction mixture at intervals and then titrate it. And in order to do that you have to use something called quenching, which means that you add an additional substance so that the reaction stops, so that you are actually measuring the amount that either the reactant or the product. That can get tricky. Another way, straightforward, is use conductivity. So if you have a change in ionic concentrations, remember ions in solution are going to conduct electricity. If I end up with neutral compounds as my products, they won't, so you can see the conductivity of the solution change or decrease as the reactants would be used up. Okay, and you can measure that directly with a conductivity meter, and we do have those that go into Logger Pro. There are also non-continuous methods of detecting change during a reaction, and these are known as clock reactions. It's difficult to record those continuously, or it's difficult to record some reactions as a continuous change. So what you do is you measure the time for a reaction to reach a fixed observable point, and then you vary the experimental conditions over time to see how long it takes. Okay, and this can only measure the average rate over the time interval that it takes. A typical application is one in which you produce a solid. So you're producing this precipitate. It's going to make that solution opaque over time. And we can go see the simulation. Or not. Give me a minute. Okay, and this is the one that is shown on the PowerPoint slide. We have sodium thiosulfate solution, dilute hydrochloric acid that we're adding to it, and we're running the reaction at 2 different temperatures. As you can see, over time, it becomes opaque, so you can't see the X. At the point you can't see the X is when you record that time frame. This happens later, which you would expect at the lower temperature. So that's an example of how would you use a clock reaction. Okay. And those are ways to experimentally determine reaction rates.